Assalamualaikum warahmatullahi wabarakatuh, and hi to our lecturer, Sir KHIRWIZAM. My name is Cik Amirul bin Cik Muhammad Zaid, and my teammates Loga Ganison and Chu Han Kai from class DKM 5B. Today we are going to presenting our case study part 2, which we will be answering the question from the case study. The question is, a standard diesel cycle is an idealized cycle for diesel engine. Sketch a PV and TS diagram and clarify for different process for the ideal diesel cycle. The picture below are the answer to our question. PV stands for pressure over volume diagram, and TS stands for temperature over entropy diagram. The four different process for ideal diesel cycle is process 1 until 2, which is isentropic compression. In this process, the piston moves from BDC to TDC and compression of air takes place isentropically. Here the air is compressed, so the pressure increase from P1 to P2, volume decrease from V1 to V2, temperature increase from T1 to T2, and entropy remain constant. The next process is process 2 until 3, which is constant pressure heat addition. In this process, the hot body is kept in contact with the cylinder, and the heat addition to the air takes place at constant pressure. The pressure remains constant. Volume increase from V2 to V3, temperature increase from T2 to T3, entropy increase from S2 to S3. The next process is process 3 until 4, which is isentropic expansion. In this process, after the heat addition, the expansion of air takes place isentropically, and work is obtained from the system. The piston moves downward during the process and reaches to BDC. The pressure falls from P3 to P4. Volume increase from V3 to V4. The temperature falls from T3 to T4, and entropy remains constant. And the last process is process 4 until 1, which is constant volume heat rejection. In this process, the piston rests at BDC for a moment, and the cold body is brought in contact with the cylinder, and the heat rejection takes place at constant volume. The pressure decreases from P4 to P1, temperature decreases from T4 to T1, entropy decreases from S4 to S1, and volume remains constant. So, moving on to our next question. Assemble, we construct a block diagram that shows how diesel engine starting system work in diesel power plant. The diagrams below are the answer to our question. The compressor draws the air from the atmosphere and compresses. The compressed air is supplied to the engine through the filter for starting, where it is compressed by a piston in a cylinder. The fuel is supplied from the tank through the filter to the fuel injectors. The fuel injectors injects the fuel into the cylinder and mix with compressed air. The injected fuel gets ignited and combustion takes place. This liberates a huge amount of energy, which is utilized to run the generator to produce the electric power. The cooling water is continuously supplied to cool the engine, and lubrication oil is supplied to lubricate the engine parts. The air intake supplies the air to the engine for subsequent operations.
Okay, question C. Sketch the layout of the basic compressed air plant. So the slide shows the basic component, the basic layout of the compressed air plant.
Question D. A positive displacement pump can be classified according to rotary and reciprocating type. And this is a picture that shows rope pump. Category of rope pump. Rope pump is a type of positive displacement pump. The way that the pump operates is liquid that taken from one end and positively discharged at the other end of every revolution. Positive displacement pumps are widely used in industrial and commercial for pumping fluids, others that water such as thick fluid oil. This is because Rope pump has high efficiency and corrosion resistance. It also has typical speed of 100 to 500 rpm. Other than that, rope pump also used in food industry and biopharmaceutical processing. This makes sense because the rubber parts in this pump is easily to sanitize. A rope pump is a rotary pump that is under the type of positive displacement pump. Rotary pump is a valveless pump in which the fluid is positively pushed by machine vanes on parallel revolving shafts and machine screws into the discharge pipe. It is similar to the gear pump except this pump designed to almost match rather than touch and turn each other. The picture below is showing how the rope pump works. Rope pumps are similar to the external gear pumps in that fluid flow around the interior of casing. Unlike external gear pump, however, the ropes do not make contact. The contact is prevented by external timing gears located in the gearbox. Pump shaft support bearings are located in the gearbox, and since the bearings are out of the pump liquid, pressure is limited by bearing location and shaft deflection. First, as the ropes come out of mesh, they create expanding volume on the inlet side of the pump. Liquid flows into the cavity and is trapped by the ropes as they rotate. Liquid travels around the interior of the casing in pockets. Between the ropes and the casing, it does not pass between the ropes. Finally, the meshing of the ropes forces the liquid through the outlet port under pressure. Rope pumps are frequently used in food applications because they are good at handling solids without inflicting damage to the product.
Question E. Vane pump is a rotary type. Illustrate vane pump by showing the liquid direction in the inlet and outlet, rotor and vanes. So this is the layout. This is the illustration of the vane pump, and this the liquid flow direction inlet and outlet, rotor and vanes.
That's all from us, and thank you for watching. And we also would like to thank our lecturer, Sir KHIRWIZAM, for this opportunity. Assalamualaikum and have a nice day.